Model-based systems engineering, MBSE, is a modern approach to systems engineering that uses models instead of documents as the primary means of communication, design, analysis, and validation throughout a system's lifecycle. Simple definition: MBSE is a method of designing and managing complex systems using visual and analytical models rather than relying heavily on traditional paper-based documents. Key concepts: concept, description, system model, a digital representation of the system's structure, behavior, requirements, and relationships. Requirements, defined and traced within the model to ensure complete and correct system functionality. Simulation and analysis, performed directly using the model to test and validate system behavior. Lifecycle integration. MBSE supports all phases: concept, design, development, test, deployment, and maintenance. Tool-based. Common tools include SysML, Systems Modeling Language, MATLAB Simulink, Cameo Systems Modeler, IBM Rhapsody. Why use MBSE? Top 5 benefits. 1. Improves communication among stakeholders using visual models. 2. Reduces errors and misunderstandings by maintaining a single source of truth. 3. Enhances system quality through early verification and validation. 4. Supports reuse of models across projects. 5. Handles complexity in large systems, aerospace, automotive, defense, etc. Example applications: industry, aerospace, designing aircraft avionics or satellite subsystems; automotive, modeling self-driving car systems, sensors, decision logic, etc. Defense, systems integration of radars, missiles, and communication platforms; healthcare, modeling medical devices with regulatory compliance. MBSE versus traditional SE aspect: traditional SE, MBSE, main output, documents, digital models, traceability, manual automated, change impact, hard to manage, visual inclusion, separate process, integrated, reuse, limited, high potential. Languages and tools used: SysML systems modeling language, most widely used for MBSE, UML, AADL, MATLAB Simulink. Tools: Magic Draw, Cameo, IBM Rational Rhapsody, PTC Integrity Modeler, Enterprise Architect. Inspiring insight: MBSE turns systems engineering into a living, breathing system where ideas evolve in real time. Question to think about: can MBSE help make future smart cities, autonomous vehicles, or space missions safer, faster, and more efficient? Here's a powerful and practical breakdown of model-based systems engineering, MBSE. Top 20 interesting things to know about MBSE. Fact insight. 1. MBSE replaces document-heavy approaches with visual integrated models. 2. It uses modeling languages like systems modeling language. 3. NASA, Boeing, and Airbus are major adopters of MBSE for aerospace projects. MBSE supports the entire system lifecycle, from requirements to maintenance. Improves traceability between requirements, design, and tests. 6. Enables early detection of design flaws through simulation and analysis. 7. Promotes collaboration between multidisciplinary teams, mechanical, electrical, software. 8. Enhances reuse of components across multiple projects. Reduces costs and time to market in complex engineering projects. Models are machine-readable, allowing for automated verification and testing. MBSE can be integrated with AI and digital twins for smarter systems. 1. SysML v2, the next generation of modeling, improves precision and usability. 1.3. Many MBSE tools offer plugins for simulations and requirements tracking. MBSE is tool agnostic, meaning you can use tools like Cameo, Rhapsody, or Enterprise Architect. Allows real-time collaboration, even across global teams. 1.6. Plays a key role in cybersecurity modeling and system safety assurance. Bridges the gap between engineers and stakeholders using visual storytelling. Helps with certification in industries with regulatory requirements, e.g., FAA, FDA. Supports agile development through iterative modeling and continuous feedback. MBSE is the foundation for digital engineering and Industry 4.0 transformation. Top 10 applications of MBSE in industry. industry application example. Aerospace and defense. Design of aircraft systems, avionics, radar, missiles used by NASA, Lockheed Martin. Automotive, autonomous driving, EV systems, battery management, e.g., Tesla, Bosch, Ford. Healthcare medtech, modeling smart medical devices ensuring safety compliance, FDA. Rail and transportation, rail control systems, urban transit, Siemens Bombardier. Telecommunications, modeling 5G networks, satellite communications, Ericsson, SpaceX. Manufacturing, smart factories, digital twins, Industry 4.0 system integration. Energy and utilities, power grid modeling, smart meters, nuclear safety, ABB. Pharmaceuticals, drug manufacturing systems, lab automation equipment. Smart infrastructure, smart cities, building automation, integrated security systems. Robotics and industrial automation, robotic arms, logistics automation, warehouse systems, Amazon Robotics. Summary: model-based systems engineering is a game changer for handling complexity, a collaborative, visual-first method for smarter system design, the future of digital engineering. Inspiring closing thought: MBSE transforms engineering into a living model where ideas, systems, and innovation evolve together. Model-based systems engineering engineer, perfect for career awareness or strategic hiring. MBSE engineer, role overview. An MBSE engineer designs, develops, and maintains model-driven systems using tools like SysML, ensuring systems are well-structured, traceable, and aligned with requirements through their entire lifecycle, from concept to deployment. Top job roles in MBSE. Role title, description. MBSE Systems Engineer. Builds and manages system models, requirements, architecture, behavior. SysML Modeler. Creates SysML diagrams, use case, block, activity, sequence, etc. Simulation and Analysis Engineer. Runs system simulations to verify behavior and performance. Requirements Engineer. Models and traces system requirements to design and test cases. Integration and Interface Engineer. Ensures consistency and compatibility between subsystems. Toolchain Integrator. Customizes and integrates MBSE tools with PLM, CAD, and simulation tools. Verification and Validation Engineer. Models test scenarios and validates them against requirements. Digital Thread Architect. Creates and manages digital continuity between design, test, and operations. MBSE trainer trains teams, defines methodology, and supports MBSE adoption. Aerospace Defense MBSE Specialist applies MBSE within specific domains like avionics or mission systems. Key skill sets for MBSE engineers. 1. Technical and modeling skills. SysML, Systems Modeling Language, Diagrams and Syntax. UML, Unified Modeling Language, Software Behavior Modeling, Simulation Tools, MATLAB Simulink, Modelica, ANSYS. MBSE platforms, Cameo Systems Modeler, IBM Rhapsody, Capella, Enterprise Architect. Systems Architecture, Functional Logical Physical Modeling. Requirements Management, DOORS, Jama Connect, Polarion. Programming and scripting, nice to have. Python, Java, or MATLAB for automation or simulation scripting. XML, XMI, model exchange formats. 3. Soft skills. Systems thinking. Understand interconnections between system components. Communication. Translating complex models for non-technical stakeholders. Problem solving. Debugging system behavior early through modeling. Collaboration. Working with hardware, software, and test teams. 4. Domain knowledge, industry specific. Aerospace, automotive, healthcare, robotics, etc. Knowledge of relevant standards, e.g. DO 178C for avionics, ISO 26262 for automotive. Standards and methodologies. INCO's MBSE methodologies, e.g. vModel, Harmony SC, Arcadia. Agile DevOps for MBSE integration. Education and certification. Requirement examples. Degree BE, BTech, MS in Systems Engineering, Electrical, Mechanical, Computer Science. Certifications, INCOS ACSCP, OMG Certified SysML Professional, MBSE Tool Certifications, Training MBSE Boot Camps, SysML Workshops, Model Simulation Courses. Job opportunities. Sample companies hiring MBSE engineers. Company industry. NASA, Airbus, Aerospace, General Motors, Tesla, Bosch, Automotive, Lockheed Martin, Raytheon, Defense, Siemens, GE Healthcare, Healthcare Industrial, IBM Dassault Systems, MBSE Tools IT. Future career path, step role. Entry, Systems Engineer, SysML Modeler. Mid-level, MBSE Lead, Tool Integrator, Domain Expert. Senior, Chief Systems Engineer, Digital Thread Architect. Expert, MBSE Consultant Trainer, INCOS Fellow. An MBSE engineer is not just a system designer, they are the architects of innovation, building tomorrow's smart systems today. Key takeaway message for newcomers to MBSE. Model-based systems engineering is not just a skill, it's a mindset. It empowers you to design, simulate, and solve real-world problems with clarity, precision, and innovation. By mastering MBSE, you're not only shaping smarter systems, you're shaping the future.